A very good morning, good evening, all of you guys. A very good evening. Welcome to an academy. Hi, zero to infinite. Good evening. Slowly, students are going to join. So I'm just waiting for the students. Once they join, we can start the session. Okay. So welcome to the marathon session on network analysis. Okay. So I think for the 23-24 aspirants, this is the first class of mine regarding the technical part or the subject session. Abhi tak we have taken many strategy sessions, and now I think that this is the first session we are discussing the subject. Okay. So before going further, there is already there are three playlists available in this channel Creatrix. Uh, One is Lakshya Batch Network Analysis by me, and Ankit sir Lakshya Batch Network Analysis also getting premiered every single day, and Tesla Batch Network Analysis, that is for the English what we call English students, English medium students. Fine. So already three playlists are available. You can watch the total content in the recorded. But what I feel, anyway, that is available in recorded, you can watch it anytime and learn. But for those who want to start these recordings, I want to give a startup boost, like to give some sort of basics on live, so that you will be able to learn properly. Then you can continue with the remaining part in the recorded of any of these three playlists. Okay, that's the intention of this particular session. So let's move further. Good evening, Ria. Okay, so let's move further, guys. So this is about my profile. This is Bhima Sankar. I did my Mtech from IIT Kharagpur. I have 10 years of teaching experience in GATE and engineering service examinations throughout the country. In the last 10 years, I taught to several thousands of students. Almost it is 11 years, we can say. In the last 11 years, I taught to several thousands of students, like you people throughout the country. So with my expertization, okay, uh, I will always try to teach the subject from the basic level where the student should not face any difficulty, even he don't have any knowledge in the subject initially. That's my main motto in any session. Okay. So today also we will be discussing in that particular way only. Right. So before going further, I want to give some inputs regarding an Academy Plus subscription. If you want to take an Academy Plus subscription, इसमें बहुत सारे benefits है, like you will be getting the live classes by top educators. You can also watch them in recorded any number of times without any restrictions. We have multiple batches. You can join any batch of your wish. You can watch multiple batches also. We have comprehensive crash batch, rank improvement batch, different batches. And also after every three sessions, we have one dedicated doubt solving session. And also we will be providing you test series, and now notes is also integrated for free for your plus subscription. इसके अलावा आपको पर्सनलाइज्ड कोचिंग चाहिए तो आप आइकॉनिक सब्सक्रिप्शन ले सकते हैं। आपको पर्सनल कोच मिलेगा, स्टडी मटेरियल मिलेगा, प्रिपरेटरी मटेरियल, वन टू वन मेंटरशिप मिलेगा, पर्सनलाइज्ड गाइडेंस एंड फिजिकल नोट्स भी मिलेगा आपको। ओके। So this is also added. So for iconic subscriptions, subscriber students आपको hard copy मिलेगा notes का, right? So all these things you will be getting with the Unacademy iconic subscription. These are the subscription prices, guys. आप मेरा code use कर सकते हैं. You will be getting 10% discount on any subscription, whether it is Plus, iconic, or any subscription of Unacademy for any duration. You will be getting 10% discount. Right. So, guys, let's start the subject. Right. So today, let's have some basic discussion on network analysis. Okay, ready? Very good evening, Karnakar. Chalo. Thank you. See guys, in your gate, whether you are from EC background or electrical background, आप कोई भी background से हो सकते हैं, network analysis का weightage तो आपको 8 to 10 marks मिलेगा gate पे और ESC में भी very good weightage you have both objective and conventional. Okay, altogether you may be getting 80 to 100 marks that we are सकते depending on the paper toughness. Last year there are around 80 marks from the network analysis in the ESC examination. Okay, so this is the weightage of this subject. Okay, and we generally discuss the subject in basics, network theorems, then two-port networks, transient or AC analysis. These are the things we have in the network analysis. Guys, this is a marathon session. This particular session पे I want to concentrate on KCL, KVL, node, mesh analysis वाला topics and इसका theory और corresponding problems जितना भी possible है तो उतना basic problems we will be doing it. If you attend this session from starting to the ending, and tomorrow also we have this session, you don't have any basic knowledge about the network analysis also, KCL, KVL आपको कुछ भी नहीं पता है तो भी you will be able to solve any basic node analysis question undoubtedly. That I can assure you. Okay. So पूरा syllabus के लिए you can follow the playlist. Okay. What is that? लक्ष्य बैच में network analysis in Hindi by I taught this, or you can, it is your convenience, you can follow any educator. Our Ankits are also teaching the same subject. You can follow any one of them. Okay, for Hindi students. Similarly, for English students, Tesla batch wala playlist pe again you see the network analysis by me. This is the only option you have for English. So आपका पूरा सिलेबस कंप्लीट करने के लिए अच्छी तरह से बहुत बहुत बेसिक से एवरी सिंगल माइन्यूट पॉइंट से आपको चाहिए तो प्लीज फॉलो दिस प्लेलिस्ट कंप्लीटली. सो आप पूरा प्लेलिस्ट फॉलो करने के पहले टुडे आई विल बी गिविंग यू जस्ट द बेसिक पार्ट बिकॉज वेयर द इनिशियल स्टार्टअप आई विल बी गिविंग यू टुडे. ओके, सो लेट्स स्टार्ट. आपका नेटवर्क एनालिसिस जो बेसिक्स है ना, बेसिक्स में हमेशा वी शुड स्टार्ट विथ ए टॉपिक कॉल्ड, कोई भी नेटवर्क आप ले लो भाई, फर्स्ट अंडरस्टैंड इट्स इंपॉर्टेंट. आपका कोई सर्क्यूट और नेटवर्क वट एवर मे बी यू स्टडी एनी सब्जेक्ट, ऑलवेज यू आर प्लेइंग विद द वोल्टेजेस एंड करंट्स, राइट? एज एन इलेक्ट्रिकल इंजीनियर और एन ईसी सर्क्यूट इंजीनियर आपका पूरा लाइफ में यू विल बी प्लेइंग विद द वोल्टेजेस एंड करंट. जे मैंने इनपुट में इतना दिया, आउटपुट में इतना आया, बीच में इतना करंट आया, पूरा गेम इज दिस वन ओनली. You will be designing these things with the transistors, diodes, whatever may be the elements you will be using. But most of the game will be giving the input and getting the or your required output, and whatever may be the conditions, different ways में इस particular branch में इतना current चाहिए, इसके लिए कैसा design करना. This is what you how you play with your electronics or electrical engineer. As an electrical engineer, what you are doing. So इसके लिए fundamentally you should know one subject, that is what we call is our network analysis, which will tell you what are the basic elements available in your network, इसका behavior कैसा होता है, So what are the elements available, how they will be behaving in their real life, I mean in the in how your network, and how to find voltage current relationships. All these things you'll be studying in your network analysis. So the first thing we should start in network analysis is always classification of elements. Okay, so in the classification of elements, we will be classifying, okay, we will be classifying how many number of elements are present. I mean, what are the different type of elements present in your network, every single thing. Okay, I'll ask Sai Kumar. ठीक है राज, डोंट वरी, दोनों लैंग्वेजेस में मैं कवर करता हूँ, कोई दिक्कत नहीं, हिंदी पे और इंग्लिश पे कोई दिक्कत नहीं. ओके, लोग फ्रॉम डिफरेंट स्टेट्स तो है, सो दोनों के लिए मैं सेटिस्फाई करना चाहिए. सो हिंदी पे और इंग्लिश पे फिर रिपीट करता हूँ, कोई दिक्कत ही नहीं. ठीक है, चलो भाई. क्लासिफिकेशन ऑफ एलिमेंट्स वी विल बी स्टडीइंग, दिस इज द फर्स्ट पार्ट. इसमें we need to study the basic classification of the network elements like active, passive, linear, non-linear, unilateral, bilateral, time invariant, time variant, lumped or distributed. These are the basic classification of the elements. So इसके बारे में आप I am not discussing in this session. इस session में मेरा intention is to cover KCL, KVL, node, mesh analysis. चाहिए तो मैं भी depending on the response of these sessions, I may take the live session for the classification of element sources later. But first, please listen carefully. So this is what we call classification of elements. बेसिकली एन एलिमेंट इज एबल टू डिलीवर द एनर्जी, उसको बोलते हैं एक्टिव एलिमेंट, नहीं है तो पैसिव. इफ द वी आई कैरेक्टरिस्टिक्स आर स्ट्राइट लाइन पासिंग थ्रू द ऑरिजिन, वाई वी एंड आई रिलेशन इज लाइक वाई इक्वल टू एम एक्स, इसको बोलते हैं लीनियर, नहीं है तो नॉन लीनियर. ओके, इफ इन बोथ द डायरेक्शन इफ एलिमेंट इज बिहेविंग गिविंग सेम इम्पिडेंस, इसको बोलते हैं बायलेटरल, नहीं है तो यूनिलेटरल. Okay, so these things anyway you will be studying in the comprehensive course. We are not touching that. The second thing, this also I am skipping, classification of sources. इसमें we will be studying generally independent, dependent. इसमें भी ideal और practical, वोल्टेज सोर्स और करंट सोर्स, ये सारे डिस्कस करना चाहिए सोर्सेस के बारे में. When we are studying about the sources, these are the things we must know. Okay, we are not going to this part also directly, we are going to discuss about the Kirchhoff laws. Okay, so let's move there. आपका पूरा नेटवर्क, नॉट ओनली पूरा नेटवर्क, आपका टोटल इलेक्ट्रिकल इंजीनियर और ईसी इंजीनियर का लाइफ में, आपका पूरा लाइफ में, पूरा जिंदगी में, please remember these particular laws. They will play a great role in any analysis. कोई भी एनालिसिस आप करना चाहिए तो उस पे नेटवर्क एनालिसिस करने पे KCL, KVL, दो किरचॉफ लॉस है ना, इसका रोल बहुत बहुत इंपॉर्टेंट. दे आर जस्ट लाइक हार्ट ऑफ योर नेटवर्क एनालिसिस. ठीक है, KCL और KVL. ठीक है, आप लोग अभी कमेंट करना चाहिए. मेरा क्लास में आपको कोई भी दिक्कत नहीं होना चाहिए. यू हैव एनी काइंड ऑफ डाउट, फील फ्री टू आस्क मी. यू आस्क मी व्हेन यू फेस एनी काइंड ऑफ मिनिमम बेसिक डाउट आल्सो, यू हैव फील फ्री टू कमेंट. आई विल बी एबल टू हेल्प यू. फाइन, आप लोग प्लीज बताओ KCL, KVL, वेयर डू वी अप्लाई दी किरचॉफ लॉस. कौन सा नेटवर्क्स में एप्लीकेबल, कौन सा नेटवर्क्स में नॉट एप्लीकेबल. कैन एनीबॉडी कमेंट फ्रॉम द ग्रुप? Right? From the group, I want anyone to comment on this. Yes, please. Can you tell me where can I apply Kirchhoff laws, where I cannot apply the Kirchhoff laws? Current and voltage laws, Ravi Verma lumped irrespective of the nature of the elements, Sai Kumar. Any other answers by anybody else? Guys, everybody please be active in the class. Please be, maybe I may take for 1 hour or 2 hours, it doesn't matter. आपका एनर्जी चाहिए मुझको. Very good. Sai and Ravi Verma, right answers. KCL, KVL, they are applicable only for lumped electric circuits. These are applicable for any lumped electric circuit. कोई भी लंप्ड इलेक्ट्रिक सर्क्यूट में आपका केसीएल केवीएल 100% एप्लीकेबल. दे आर इंडिपेंडेंट ऑफ नेचर ऑफ द नेटवर्क. जैसा ट्रैफिक सिग्नल होते हैं, ट्रैफिक सिग्नल कैसा है भाई? इन जंक्शन वॉट एवर मे बी द व्हीकल सेंटर्स, जो व्हीकल्स आएगा ना, इट मे बी बस, इट मे बी ट्रक, इट मे बी साइकिल, इट मे बी स्कूटर, कोई भी व्हीकल आएंगे तो सिग्नल रिमाइंस द सेम 99%. ओके, सो whoever enters सिग्नल होने के बाद जाएगा. द सेम वे नेटवर्क एनालिसिस में केसीएल केवीएल में ड्यूरिंग द केसीएल केवीएल दे आर एप्लीकेबल फॉर एनी लंप्ड इलेक्ट्रिक सर्क्यूट्स. Lumped means physically present. Okay, any lumped electric circuit में KCL KVL applicable. They can be linear, non-linear, active network, passive network. It doesn't matter. Okay, so इसको बोलते हैं independent of nature of elements. Independent of nature of elements. They are heart of your network analysis. कोई भी analysis आप करने के लिए you should be very clear in KCL KVL. बहुत लोग को मैंने देखा बीटेक होने के बाद, एमटेक होने के बाद भी उन लोगों को केसीएल केवीएल में थोड़ा सा दिक्कत है. नोड एनालिसिस में दे डोंट नो द बेसिक्स. ओके, सो आप उस कंडीशन पे नहीं होना चाहिए. केसीएल केवीएल नोड मेश में यू शुड बी वेरी परफेक्ट, 100% एक्यूरेसी होना चाहिए इस वाले टॉपिक में. सो लेट्स मूव गाइस. Right. So where do we apply KCL? Means के सर KCL is applicable at a node बोलते हैं. सर node का मतलब क्या सर? Node का मतलब it is a junction point. Junction point का मतलब it is junction of the branches. So generally nodes are two types guys. Simple node, principal node. Simple node का मतलब इंटरकनेक्शन ऑफ दो ब्रांचेस हमने जंक्शन में कनेक्ट किया तो इसको बोलते सिंपल नोड. प्रिंसिपल नोड को ये बोलते इफ यू कनेक्ट मोर देन टू, दैट इज 3 4 एनी नंबर, इसको बोलते प्रिंसिपल. लेट मी रिपीट, केसीएल इज एप्लीकेबल एट ए नोड. नोड का मतलब क्या सर? नोड का मतलब इट्स ए जंक्शन. ओके, इंटरकनेक्शन ऑफ द ब्रांचेस. इफ यू कनेक्ट ओनली टू ब्रांचेस इट्स ए सिंपल नोड. If you connect more than two, it's a principal. Let me give you the example. Suppose this junction point is there, right? This is an example of simple node. That is interconnection of Kvl or Kvl दो ही branches in this shape or in this shape, whatever it might be. अगर आपने 3 branches ऐड किया तो 3 or more than 3. Then इस केस में इसको बोलते हैं the junction node जो होता है ना, इसको बोलते हैं principal node. आपका जो KCL है ना, it is applicable at simple node and also at the principal node. KCL is applicable at both the nodes. It can any kind of node पे KCL is applicable. Okay, let's move. Fine. Suppose right, listen here. मेरा पास different type of branches connected like this. Okay, there are what is the meaning of the definition of the KCL? I want to explain you. इसके लिए please listen carefully. Suppose you have these kind of branches. Okay, suppose there are three pipelines. Okay, like this. So ये तीनों मैंने joined किया. Okay, so there are three pipelines. Okay, so इसमें पानी जा रहा है. Okay, so suppose I have connected three pipelines like this. Water may be coming from each pipeline. आपका common sense से आप ये बोल सकते हैं भाई, अरे भाई, is it possible for water to enter from all the pipelines? सारे पाइपलाइन से पानी जंक्शन पर जा सकते क्या? नहीं जा सकते सर, जंक्शन तो ब्लास्ट हो जाएगा सर. Okay, fine. Is it possible from all the nodes, all the branches, all the pipelines से पानी बाहर जा सकते क्या? Is it possible that water can flow outside from all the branches, all the pipelines? Impossible. It will create vacuum. So, आपका law of conservation of energy or whatever may be the condition, if you take, we can say one thing: at any junction, at any given time, there may be some lines which will be entering water, and some lines से पानी बाहर जाएगा. कुछ पाइपलाइन से पानी अंदर आएगा, कुछ पाइपलाइन से पानी बाहर जाएगा. एट एनी गिवन टाइम एट दिस जंक्शन जो पानी आ रहा है ना, जो पानी जा रहा है ना, इक्वल होना चाहिए. दैट इज व्हाट वी इनडायरेक्टली से इट एज ए केसीएल. केसीएल में हमने ये बोलना चाहिए, इन एनी इलेक्ट्रिक सर्क्यूट एट एनी गिवन टाइम ऑफ टाइम, कोई भी इलेक्ट्रिक सर्क्यूट ले लो भाई, कोई भी टाइम पे. ओके, एट एनी गिवन नोड, इट कैन बी सिंपल नोड और प्रिंसिपल नोड, कोई बात नहीं भाई. You can take a simple node or principal node, no problem, at any given node. The algebraic sum of the currents leaving the node is equal to 0. ठीक है? Or the current entering the node हमेशा equal to current leaving the node. All the currents cannot be entering the junction. All the currents cannot be leaving the junction. This is what given by our Kirchhoff's current law. Now read this point, guys. In a lumped electric circuit for any of its nodes at any time t, the total sum of the currents leaving the node is always equal to 0. Okay, sir, आपने बताया entering equal to leaving, but here you are saying sum of the currents leaving the node is 0. नहीं भाई, algebraic sum of currents leaving the node equal to 0. इसका मतलब with the example I will be explaining you. Don't worry. Listen. Let's take one example. मेरा पास 5 ब्रांच है भाई. Current is randomly taken. ये आपका जंक्शन, आपका नोड. आप ही बताओ what is your KCL? Algebraic sum of currents leaving the node is equal to 0. A KCL है भाई. So I1 is entering the node. अरे भाई, आपका आदमी I1 नोड पे आ रहे. If it is entering, मैंने बताया sum of currents leaving the node equal to 0 ना. If this is entering, take minus I1 is leaving. I1 is entering means how much is leaving? Minus I1. Similarly, I2 तो जा रहे भाई, take plus I2. Many people might know this already, but maybe you might miss some basics. That basics also will be given today. Please wait. Everybody, whether you have some level of the subject, you don't have any level of the subject, you always have something to learn. Please wait for some time. You can realize that. ठीक है? और I3 भी एंटर हो रहा है भाई, आप बताओ माइनस I3. I4 भी एंटर हो रहा है माइनस I4. I5 तो लीव हो रहा है प्लस I5 इक्वल टू 0. सो क्या बोलना चाहिए मैंने? I1 प्लस I3 प्लस I4 क्या होता है सर? I2 प्लस I5। कोई भी नेटवर्क पे ले लो भाई, द सम ऑफ करंट्स एंटरिंग द नोड हमेशा इक्वल टू सम ऑफ द करंट्स लीविंग द नोड at any given point of time. This is another way to express the KCL. दोनों सही है। Algebraic sum of currents leaving the node equal to zero. Perfect. The same way, sum of the currents entering the node is equal to sum of the currents leaving the node. This is also correct. Is it fine? Let's move. आपको भी पता है करंट का इक्वेशन, इज देयर एनी रिलेशन बिटवीन करंट एंड चार्ज? आप लोग कमेंट करना तो कमेंट करो, बताओ करंट और चार्ज का कुछ रिलेशन है क्या? यस प्रशांत, आई कैन अंडरस्टैंड योर क्वेश्चन। आरएलसी इज प्रेजेंट इन द ट्रांसमिशन लाइंस, आर दे लंप्ड और नॉट? वो तो लंप्ड नहीं है भाई, बट वो डिस्ट्रीब्यूटिव एलिमेंट्स, उसको हम लंप्ड जैसा अप्रोक्सीमेट करके एनालिसिस करेगा। We will be approximate the distributive nature of the network into lumped to make the analysis, because this analysis is applicable for lumped. Okay, क्वेश्चन प्रैक्टिस भी आएगा भाई थोड़ा सा थियरी के बाद रवि। ओके, वेरी गुड रिया, राइट आंसर। चलो चलो लिसन हियर, करंट आई इक्वल टू व्हाट? डी क्यू बाई डी टी। करंट आई क्या होता है सर? डी क्यू अपॉन डी टी, राइट राइट। सो यूजिंग दिस लॉजिक मैं ऐसा बोल रहा हूँ, डी क्यू वन बाई डी टी, डी क्यू थ्री बाई डी टी, डी क्यू फोर अपॉन डी टी क्या होता है सर? सो डी बाई डी टी कॉमन लेके इंटीग्रेशन अप्लाई किया तो आपको क्यू वन प्लस क्यू थ्री प्लस क्यू फोर, क्यू टू प्लस क्यू फाइव। चार्ज एंटरिंग द नोड इक्वल टू चार्ज लीविंग द नोड, इसको बोलते हैं लॉ ऑफ कंजर्वेशन ऑफ एनर्जी। दिस इज अनदर वे टू एक्सप्रेस योर केसीएल। केसीएल का फाउंडेशन तो ये है लॉ ऑफ कंजर्वेशन ऑफ एनर्जी। लेट मी टेक सम वाटर। लेट्स मूव। So that is about your basic KCL. मैं theory थोड़ा सा crispy रखा, okay, not much, little immediately दे रहा हूँ, so that we can move to the problems also, okay, in this available time. So this is what I want to give you guys. So first thing, basic KCL पे कोई दिक्कत ही नहीं है ना, कोई भी नेटवर्क में हमेशा प्लीज लिसन, आपका माइंडसेट ऐसा होता है, if the things are very easy, अरे you feel that you are not learning anything new. If things are very difficult, you feel that it is very difficult, I may not be able to answer the exam. Okay, so please don't keep any this kind of prototypes in your mind. आप आराम से बैठो, थोड़ा सा टाइम, थोड़ा सा देर वेट करो, definitely you will be enjoying the things. So हमेशा our process, we will be going from zero level. Okay, so first initially you may feel that things are very easy, very easy. Over a period of time we will be learning many things. Okay, so please pay attention. Let's move further. So that is about your KCL, guys. Algebraic sum of currents leaving the node is equal to zero. After, I will be giving you KVL, node analysis, mesh analysis. Then we will be doing the problems. That is what we are going to do in this single session. Okay, chalo. KVL. So similar to KCL, okay, there is another thing called Kirchhoff's voltage law. मैंने बताया केसीएल इज अप्लीकेबल एट ए नोड। कहां पे अप्लीकेबल सर? केसीएल नोड पे। आप ही बताओ केवीएल कहां पे अप्लीकेबल? केवीएल कहां पे अप्लीकेबल? प्लीज टेल मी, प्लीज कमेंट वेयर वी कैन अप्लाई केवीएल। ओके, प्लीज टेल मी, मैं तो वेट कर रहा हूं आपका कमेंट के लिए। वेरी गुड, वेरी गुड। सो गाइस टेल मी यार, where can I apply KVL? ओके, प्रशांत ने बोला क्लोज्ड लूप. एनी अदर आंसर? KVL is applicable in a closed loop is what is the answer given by Prashant. Okay. In a mesh, very good. Another Prashant. दोनों प्रशांत है. मस्क ने दिया loop. ठीक है. Fine, चलो. So this is a basic class. Please remember. Okay, there are many things you need to learn. So let me check whether your answer is correct or not. एक लोग बोल रहा है क्लोज्ड लूप, अनदर लोग बोल रहा है लूप, मैश, व्हाटएवर मे बी. सो लेट मी चेक. सो आई वांट टू गिव यू फोर फिगर्स. आप ही बताओ विच पर्टिकुलर केस में केवीएल इज एप्लीकेबल, विच पर्टिकुलर केस में केवीएल नॉट एप्लीकेबल. ओके. You have the three choices. You tell me out of these three, in which particular network KVL is applicable? 1, 2, 3, 1, 2, 1, 3, 2, 3, or 1, 2, 3. You please respond your answer. Everybody in the live. Everybody in the live, please respond and give your answer, guys. मैं तो wait कर रहा हूँ आपका answer के लिए. So please tell me out of these three options, which one you feel correct. None to diya 1 and 3. Riya to diya all of them. Prashant to diya 1 and 3. Very good. Tell me. Everybody participate, yaar. It will be fun if you are participating in the class. Always you will be involving and you will be learning better. So please participate. I'll be more happy if you participate actively in the class. All of them. Tell me, yaar. Any other? Any other? There are many students in the class. Everybody's response I need. Very good, very good, very good. So Cosmos and many students are giving the answer all. Yes, all is the right answer. Okay, some of you still have the doubt. They are saying 1 and 3 only. 100% undoubtedly KVL is applicable here also. Okay. So some people commented loop, some people commented closed loop, some people commented mesh. Let me explain, guys. KVL is applicable in any loop. Any loop. Simply you should say loop. What is the meaning of loop, sir? Closed path. No need to say closed loop. Okay. Closed loop नहीं बोलना चाहिए. Simply you say loop, that's sufficient. क्योंकि loop का मतलब ही closed path. What is the meaning of the loop is nothing but a closed path is called as a loop. Understand? Okay, let's move. I will explain you. Okay. Now, firstly, what is KVL? Still आप लोगों को ये डाउट है, सर ये तो क्लोजर नहीं है ना, यहीं पे KVL कैसा applicable है सर? This is not closed, sir. How do you apply KVL here, sir? I will be explaining that, sir, for you guys. So please wait for a few minutes. I am there for you to explain that. So keep that in your mind. Definitely, I'll be helping you. Okay, fine, very good. Chalo. Right. Firstly, definition of the KVL के पहले, it is applicable. It is applicable in any loop. So in a lumped electric circuit, lumped to compulsory by for any of its loops. Okay, loops. It's not oops. It's loops, and at any time t, the algebraic sum of the branch voltages around the loop is equal to 0. The algebraic sum of the branch voltages around the loop equal to 0. Now let me explain that with the help of example. So keep this point in your mind handy. In any passive element, like resistor, inductor, capacitor, current always enters from positive and leaves from negative. Got it? So this point, keep it in your mind. In any passive element, current enters from the positive and leaves from the negative. This is the point. Please keep it in your mind. Okay. So now you have some sort of circuit like this. Say this is my RLC network. Here I want to apply my KVL. Okay, please listen carefully. So here what to do? So first thing, assume source is giving the energy. Source आपको energy दे रहा है by source energy दे रहा है तो current कैसा जाएगा यहीं पे जाएगा. So the current कहाँ से enter करते भाई कहाँ से leave करेगा भाई? Current enters from here, leaves from here. Right? Understand? Current enters from positive, leaves from the negative. So what is this value? These polarities we are only assigning, assuming the current direction. Based on the current direction, we have given the polarities. Okay, so let's give this the name VR, VL, and VC. Okay, so apply KVL. Start from here and here. That will make a loop, closed path. Okay, so according to the KVL, सो वेरी सिंपल रूल आपका माइंड पे रखो जैसा प्रीवियसली मैंने बताया लीविंग इज पॉजिटिव एंटरिंग इज नेगेटिव यू कैन डू द रिवर्स आल्सो द रूल इज ओके ओके फाइन द सेम वे अनदर रूल हियर आपको अब जा रहे हैं ना जाने समय पे आप नेगेटिव से पॉजिटिव जाएंगे तो प्लस ले लो पॉजिटिव से नेगेटिव जाएंगे तो माइनस ले लो सो आई एम मूविंग फ्रॉम नेगेटिव टू पॉजिटिव प्लस v of t when I am moving from positive to negative minus VR minus VL minus VC. So what is your V of t? V of t क्या होता है सर? Right. Generally voltage is given by energy required per charge. नाउ डी बाई डी क्यू दोनों साइड पे कॉमन लेके इंटीग्रेशन अप्लाई करो चेक करो डब्ल्यू डब्ल्यू आर प्लस डब्ल्यू एल प्लस डब्ल्यू सी इसको बोलते हैं लॉ ऑफ कंजर्वेशन ऑफ एनर्जी ओके सो केवीएल का बेस our foundation is nothing but law of conservation of energy we know we cannot violate the law of conservation of energy so कोई भी नेटवर्क वैलिड है तो द वैलिड नेटवर्क आपका एनालिसिस ऑलवेज शुड बी सपोर्टेड बाय केसीएल और केवीएल ये दोनों आपको हमेशा मदद करना चाहिए आप कोई भी एनालिसिस करो भाई अगर केसीएल केवीएल सेटिस्फाई नहीं हुआ तो आपका एनालिसिस गलत है भाई this is the foundation or fundamental rule which is required to solve any network analysis problem आप कोई भी network analysis problem solve करना तो ये point आपका mind पे रखना चाहिए your analysis must be supported by KCL और KVL fine so let's move further अभी आप वापस आ रहा हूं मैंने आपका डाउट पे sir please tell me how this is closed path sir how this is a loop sir how I can apply this here what we call KVL so let me explain that chalo listen here yeah Okay, let's take this as V. Okay, this as VR and this as your V naught. Assumption है भाई, ठीक है? And this my current, assume करो, ठीक है? So यही पे शुरू करके वापस सेम लोकेशन पे आओ. मैंने बताया क्लोज्ड पाथ. आप जो डायरेक्शन पे जा रहे हैं ना, आपका पाथ क्लोज होना चाहिए, नेटवर्क क्लोज नहीं होना चाहिए. नेटवर्क मस्ट बी क्लोज्ड फॉर द करंट पाथ. इसमें करंट नहीं जाएगा, कोई डाउट ही नहीं है भाई. करंट तो नहीं जाएगा, बट द ट्रैवर्सल पाथ, हमारा एजम्पशन पाथ मस्ट बी क्लोज्ड. नेटवर्क ओपन और क्लोज डजंट मैटर. इफ योर ट्रैवर्सल पाथ क्लोज है तो इट्स इनफ, यू कैन अप्लाई योर केवीएल. ठीक है? सो यही पे नेगेटिव टू पॉजिटिव वी, पॉजिटिव टू नेगेटिव माइनस वी आर, पॉजिटिव टू नेगेटिव माइनस वी नॉट इक्वल टू जीरो, वी इक्वल टू वी आर प्लस वी नॉट. बट हियर VR is equal to 0 क्योंकि करंट 0 है तो ड्रॉप 0, then V equal to V naught is the answer. सही है ना? You understand now? It's applicable that you can apply KVL even the network is open. So here also, this is one loop, this is one loop, and this whole is also another loop. Then what is mesh, sir? A mesh, ये भी मैश, बट द क्लोज्ड वन नॉट ए मैश. मैश के अंदर दूसरा लूप नहीं होना चाहिए, इट विल अवॉइड द रिडंडेंसी. ठीक है? सो मैश लूप के अंदर दूसरा लूप है तो भी ठीक है, कोई भी क्लोज्ड पाथ ले लो, इट इज कॉल्ड एज लूप. बट मैश ऐसा नहीं भाई, इसलिए आई डोंट से दैट इट इज एप्लीकेबल ओनली फॉर मैश, इट इज एप्लीकेबल फॉर लूप, एनी क्लोज्ड पाथ. ओके? मैश इज अ सबसेट ऑफ लूप. Any mesh is a loop, but any loop need not be a mesh. That's all about your basic of your network analysis, the very heart of your network analysis, KCL, KVL. Cover KCL, KVL say you cannot solve the network. You can take the help of Ohm's law, which will give you the node analysis and mesh analysis, which in turn help you to solve any network in the many cases. So if you are ready and if you are clear up to now, we can move for the node and mesh analysis theoretical part. इसके बाद we will be moving for the problem. So are you ready? If you have any kind of difficulty, please feel free to comment. I'm just waiting for your comments. Thank you, Prashant. Thank you very much. Guys, मैं तो आपका आंसर के लिए वेट कर रहा हूँ. So any kind of queries, I am very happy to answer you. Please respond, guys. आप लोग comment करो. I can see your comments and accordingly I will be moving further. Is it clear everything up to now? No doubts or any doubts? Feel free to ask me. No doubts, fine. Shall we move further for node and mesh analysis? Very good. Chalo, let's move. Thank you. Thank you. Fine. Okay. Let's move for the next part, that is node and mesh analysis. There are many things to discuss, guys. Positive impedance क्या होता है? Negative impedance क्या होता है? Voltage source, current source में current direction can be anywhere, or its impedance can be positive, negative. Passive element impedance is always positive. These things I do in the regular class. But this is a marathon session. I am little skipping all those parts. But if you want, you can see the comprehensive course. इसमें सभी every single detail आपको मिलेगा. So let's move here. Ohm's law. It is applicable only for, can you tell me? What is Ohm's law? Is it is applicable only for what kind of networks? I need your response. It is a very basic. Plus 2 pay you might have studied. Please tell me here. Okay. None. Mesh का repeat करना. Please wait. Let me continue. I'll explain. Don't worry. Okay. Tell me. Yes, very good. Linear. Okay. It is applicable for linear networks or linear elements. So let me clear the doubt of none. Please see none. This is a loop and also mesh. This two number AB loop hai by AB mesh hai. There is another thing from here to here. तीन नंबर जो है ना ये तो लूप बोलते हैं बट यू कैन नॉट से इट एज ए मैश मैश के अंदर दूसरा मैश नहीं होना चाहिए दैट इज लूप इनसाइड लूप नो प्रॉब्लम एनी क्लोज्ड पाथ इज ए लूप बट मैश ऐसा नहीं भाई इसको वी कॉल दिस एज ए लूप ओनली बट वी कैन नॉट कॉल दिस होल एज ए मैश बिकॉज इसके अनसाइड अनदर क्लोज्ड पाथ इज अवेलेबल सो टू अवॉइड द रिडंडेंसी वी कैन यूज द मैश इन द एनालिसिस which will reduce the number of equations required to solve your network. Chalo, let's move here. Guys, let's stop here. V equal to Iz is applicable only for linear elements. What are linear elements, guys? Please tell me what are the linear elements? What are the linear elements? Resistor, inductor, capacitor. Ohm's law is applicable. Okay. Your resistor may V equal to IR. इंडक्टर में वोल्टेज अक्रॉस द इंडक्टर इज L di by dt और करंट इन द इंडक्टर इज 1 by L इंटीग्रल माइनस इनफाइनाइट टू t v dt. बेसिक्स कैपेसिटर में करंट इन द कैपेसिटर C dvc by dt वोल्टेज अक्रॉस द कैपेसिटर 1 by C right. So these are the things. Understand, this is what we call the base of the Ohm's law. V equal to Iz, you can write it as j omega Li 1 by j omega C, वो तो अलग बात है. But listen carefully. Why I am saying all these things? Ohm's law not applicable for sources. What are the voltage source, current source जो होते हैं ना इस पे Ohm's law is not applicable because they are non-linear. Understand? Please listen. If you take a resistor V equal to IR, this is the voltage current relationship. What is this element? 100% linear. Ohm's law is applicable. 100% correct. But if you take a voltage source, voltage source का voltage is always constant. Current can be any value. Accepted or not? Voltage source है तो you have a 10 volts. You connect 1 ohm, it will give you 10 ampere. If you connect 2 ohms for the same 10 volts, आपको कितना मिलेगा 5. सो करंट तो वेरिएबल होता है बट वोल्टेज हमेशा रिमाइंस कांस्टेंट. इसमें इट्स ए स्ट्राइट लाइन बट नॉट पासिंग थ्रू ऑरिजिन. इसको बोलते हैं नॉन लीनियर रिलेशनशिप. ठीक है. सो इस केस में ओम्स लॉ इज नॉट एप्लीकेबल. इस केस में ओम्स लॉ इज एप्लीकेबल. व्हाई आई एम एक्सप्लेनिंग दिस? बिकॉज ये बेसिक है आपका नोड एनालिसिस अच्छे से समझ होने के लिए, इसलिए मैं सभी दे रहा हूं. ठीक है, बेसिक. So now let me give you one example. I want to test your basics. Everybody, please comment. What is the answer for this? ये तो बहुत बेसिक क्वेश्चन है ना. Many people might be knowing it. Please respond that. Very good, Siddharth. Perfectly correct. कुर्बानी, हेलो. ट्रांजिएंट के थोड़ा सा दिन के बाद प्लान करेगा. अभी तो मेरे पास कुछ ऐसा कुछ प्लान नहीं. ओके, we can plan that, not an issue. Everybody please comment here. What is the equivalent resistance? 10 parallel with 10. I need your answer. Please respond. Tell me. Five. Yes. Okay. Why I'm asking this silly questions is इसके लिए there is a reason. Okay, don't think ये why he is asking this time waste हो रहा है, ऐसा कुछ नहीं. So I have a 10 ohm resistor, 10 volt source. नहीं 1 ampere source. Now इसको मैंने 100 volts और 10 volts को कनेक्ट किया फॉर एग्जांपल. ठीक है. सो पैरेलल पे वोल्टेज इज सेम. 10/10 करंट कितना होता है सर? 1 एम्पियर. ये ऑलरेडी 1 एम्पियर. 1+1 करंट सोर्स बाय 1+1 मिलके कितना होता है? 2 एम्पियर. What is this current? 2 ampere. Can you tell me what is the input resistance of this network? Input resistance is input voltage by input current, 10/2. What is that? 5 ohms. Okay. Right. Fine. Very good. So here input resistance is 5 ohms. Please listen here. So इस वाला जो पार्ट है ना, it is equal to 5. So 10 parallel with some current source is giving me 5. Okay. So 10 parallel with 10 is giving me 5. 10 parallel with the current source giving me 5. इसका मतलब क्या है भाई? इसका मतलब क्या? इसका मतलब it is resistance is 10 ohms. Accepted or not? इस particular question पे इस current source का resistance is how much? I can say Rin is equal to 10 parallel with the source resistance of the current source. This is given as 5. Compulsory Rs must be 10 because 10 parallel with 10 is 5. ठीक है. Fine sir. But that is the resistance of the current source. Okay. What is its voltage? 10. What is the resistance of the current source? Voltage by current ratio 10 ohms. So what I want to say, this current source in this particular figure like a 10 ohm resistance. इस वाला प्रॉब्लम पे ये 1 एम्पियर सोर्स जो है ना, ये कैसा काम कर रहा है भाई? 10 ओम रेजिस्टर जैसा काम कर रहा है. ठीक है सर, अंडरस्टैंड. सो इसमें कोई भी दिक्कत नहीं है ना? Is it okay for everybody? This, as you know, 10 parallel with 10 is 5 and 10 parallel with some current source also giving me input resistance of 10/2 which is equal to 5. I can say this is equivalent to 10. Or another way I can say is its voltage by current ratio will give you the resistance of 10 ohms. So 10 parallel with 10 is 5 is also correct. So I can say is wala current source resistance in this network configuration is how much? 10 ohms. Accepted everybody? Everybody, is this clear? Everybody, is this clear? Please respond. Okay. Tell me yaar, every single student here, is this point clear? मैं जो बोल रहा हूं, मेरा पास ये सोर्स है भाई, ये दोनों एलिमेंट्स में पैरेलल में कनेक्ट किया, पैरेलल पे वोल्टेज सेम, वोल्टेज बाय रेजिस्टेंस विल गिव यू करंट, ये दोनों करंट ऐड किया तो यहीं पे इनपुट करंट आया, इनपुट वोल्टेज बाय इनपुट करंट गिव्स मी इनपुट रेजिस्टेंस, मेरा को इनपुट रेजिस्टेंस तो आया. And I can also say the input resistance is nothing but 10 parallel with the resistance of the current source. 10 parallel with the resistance of the current source 5 hai to compulsory the resistance of the current source must be 10. So I can say resistance of the current source is equal to 10 by 1. So this method is giving me 10 and this method also giving me 10. So I can say the resistance of the current source in this question is 10 ohms. Fine. Right? Now I am asking you a question. Now I am asking you a question. Listen carefully. आप प्रीवियस स्लाइड पे मैंने ये बोला Ohm's law chacha, Ohm's law is not applicable for the sources. It can be voltage source, it can be current source. Non-linear case में Ohm's law is not applicable. But यहीं पे मैंने Ohm's law apply किया. For the source resistance is V by I. It is giving the right answer. So is it applicable for sources also? Comment your answer. Do you understand what I am saying? I said Ohm's law is not applicable for the sources, right? But मैं तो अभी Ohm's law apply करके resistance निकाला, I got the right answer. So I am, can I say that Ohm's law is applicable for sources also? Is my question. Comment. How do you defend this here? Tell me. Everybody else, if you have already attended my class, so okay, no need to give the answer. But if you have not attended my class अभी तक, आप जो लोग अभी तक का मेरा क्लास अटेंड नहीं किया वो लोग देना चाहिए आंसर, मैं उन लोगों के लिए वेट कर रहा हूँ. Sometimes but not all times. Independent current source. Any other answer? सिद्धार्थ जो बोल रहा है नो. ओके यस. मेरा friends, my dear friends, please listen. No, Ohm's law is not applicable here also. Resistance is voltage by current accepted, but original point in the Ohm's law क्या भाई? V proportional to I पे ये Z जो है ना ये क्या होना चाहिए? कांस्टेंट होना चाहिए. प्लीज अंडरस्टैंड, मिसकंसेप्शन तो अवॉइड करो. Z हमेशा V by I होता है भाई. Z हमेशा V by I. Z is always V by I. Whether it is a passive element, active element, linear, non-linear, कोई भी element में Z हमेशा V by I. But that Z is constant only in the linear elements. If Z is constant, you get V and I are proportional to each other. Here Z is not constant. How, sir? Let me prove, sir. ये तो 1 एम्पियर, ये तो 10 ओम, ठीक है, सही है. पैरेलल पे वोल्टेज सेम 10 by 1, 10 by 1. ओके. ये तो 1 एम्पियर, ये पैरेलल पे 10, 10 by 10, 1. This will give me 2. Okay. So here 2 and the resistance is 10 by 2, 5. Right. Fine. But the second question, the same circuit but input is changed. Now what happens? This will become 100 and this will become 100. Okay. Same 1 ampere. but this is 100. 100 by 10 kitna? 10 ampere. Input will become 11 ampere. Now the input resistance is changed to 100 by 11. So here 10 parallel with RS is 100 by 11. The RS value you get will not be same as the previous case. क्योंकि अभी RS कितना? Voltage 100 by current 1, 100 ohms. इस केस में RS कितना? 10 by 1, 10 ohms. But here ऐसा नहीं. This resistor का resistance हमेशा constant 10 by 10. Sorry, 10 by 1, 10 ohms. 10 by 10, 10 ohms. It remains as 10 ohms irrespective of your input. But this fellow का resistance हमेशा changes with respect to input. अगर negative input दिया तो its impedance may be negative also when it is delivering. That's a different case. So that's why here a Ohm's law is not applicable. का मतलब R is हमेशा V by I, but that R is not a constant value. That's why we say sources में Ohm's law is not applicable. Here Z is not a constant. Understand? Now the Ohm's law without any misconceptions. Right. Let's move for the node and mesh analysis. I hope it is clear. Okay, everybody. Fine. Now, kindly please don't eagerly wait for the problems which comes in your GATE exam. Okay, directly problems kiya to you will be missing the fun of learning. Hamesha learn the enough theory. After that only we must solve the problems conveniently. Okay, chalo. Nodal and mesh analysis. ठीक है, node and mesh analysis. Just a moment. Fine. So node and mesh analysis के बारे में let's start the discussion. Okay, we discuss KCL, we discuss KVL, we discuss Ohm's law. If you merge KCL Ohm's law, KVL Ohm's law, आपको node, आपका mesh मिलेगा. चलो. So KCL and Ohm's law together आपका node analysis देते हैं भाई. KVL and Ohm's law आपको mesh analysis देते हैं. So KCL, KVL आपको पता है they are not depending on the nature of the elements. वो भी linear, non-linear, active, passive. कोई भी केस में applicable. But Ohm's law only for linear. We cannot apply Ohm's law for the sources because of its non-linear nature between V and I relationship. Okay, chalo. So let me start the node analysis. इसके लिए let me take one network for your better understanding. Okay. Right. So this is my network. I want to apply node analysis to this network. Let's apply to this network and learn the node analysis and apply on the problems and solve the problems today. Okay, chalo, let's start. ब्रेक तो नहीं दे रहा हूँ, ब्रेक चाहिए तो बताओ. 2 घंटा मे बी आई विल टेक 1 more hour and finish it off. 2 hours, I hope it is manageable. Harshit, Sashi, hi. आपको डिनर ब्रेक चाहिए तो खाना कर लो भाई. Parallelly listen to the class. I don't have any issue. Okay. I cannot eat, but आप लोग तो you can happily eat and listen to the class. Okay. चलो, let's move. Right. So this is the network I have, and I want to apply the node analysis to this particular network. Let's see how I can apply the node analysis to this particular network. Okay. Sure. So I have some set of rules which I need to apply so that it will be always easy when you apply the node analysis. So first point here, identify the number of nodes. इस वाला circuit में कितना nodes है भाई? Let's identify that. Please comment how many nodes are present in this network. Please respond यार. जितना कितना nodes है? How many nodes are available? ओके. कॉस्मोस राइट. प्रशांत तो चार बताया, चार नहीं भाई, तीन. 1 2 3. ओके, बिकॉज ये सारे एक ही है ना. You have this intermediate nodes also, A, B, but we should consider only these three. These are called principal nodes. Forget about AB. Okay, because if you include all of them, it becomes complex. ज़्यादा टाइम लगेगा, ज़्यादा एनर्जी चाहिए सॉल्व करने के लिए. इसके अलावा we solve for the principal nodes, then from that if required we can obtain for the simple nodes. चलो, let's move. Okay. Okay, fine. Listen. So 1, 2, 3 called as principal nodes, A, B are called as simple nodes. Okay, fine. So here in this first point तो हो गया. Second point क्या? Assign the node voltage with respect to the ground or reference node voltage whose voltage is always equal to 0. This is the most important point in your nodal analysis. Many people have the confusion in this point. So इसके लिए मैं general example से explain करता हूँ so that there will not be any confusion for you guys. So please listen here. आपके लिए मैं एक general example ले रहा हूँ. See here. एक नॉर्मल एग्जांपल ले रहा हूं, ठीक है. सपोज यू हैव ए पानी वाला टैंक ए, इसका हाइट 10 मीटर्स. दूसरा टैंक भी है आपके पास, इसका हाइट 20 मीटर्स. सपोज ये दोनों बीच में एक पाइपलाइन मैंने कनेक्ट किया टैंक ए और बी का बीच में. ओके, इफ वी कनेक्ट pipe between tank A and tank B, then water will flow from where to where. आप लोग कमेंट करो A to B or B to A, or you don't know or you cannot comment. Please respond. सी मस्क सिंपल का मतलब दो ही ब्रांचेस. स्टार्टिंग पे मैं एक्सप्लेन किया हियर जंक्शन पे दो ही ब्रांचेस है तो ना, ये दोनों को बीच में नोड, ये दोनों को बीच में है तो सिंपल। प्रिंसिपल में मोर देन टू नोड्स, मोर देन टू ब्रांचेस। चलो, कैन यू कमेंट? ओके, टैंक तो पूरा फिल किया। फुल टैंक ले लो एग्जाम्पल पे। ओके, सो फुल टैंक ले लिया तो ए टू बी और बी टू ए, और वी कैनॉट से, लेट अस सी, इट डिपेंड्स ऑन द ग्राउंड लेवल ऑफ द टैंक। It depends on the ground level of the tank. We cannot say A to B or B to A, guys. Okay, listen here. Suppose you have a tank at a height of 20 meters. Second tank is on a building which is already a 15 meters or some hill, whatever may be. इसमें मैंने टैंक कंस्ट्रक्ट किया which is Kvl 10 meters. But क्या advantage है here? Already with respect to the ground level, it is at a 25. So A to B जाएगा, अभी इस केस में B to A जाएगा. It depends on the relative here. Individual height not important. Relative difference in the height important है भाई. With respect to one reference point, you can measure from this or you can measure from this also. You can take this as also reference. कोई दिक्कत ही नहीं है भाई. But it will be, what is that, 5, it will be 10, so the difference will be more from B to A, आपका पानी जाएगा। The same analysis is applicable on your network analysis। आपका करंट जाने के लिए आपको क्या चाहिए? वोल्टेज डिफरेंस चाहिए। So it is not the individual voltages which are important, we should measure the voltages with respect to a common reference point, इसको बोलते हैं ground node। Understand? Here there is a ground level. With respect to this common node, common point, we measured the height. The same thing we apply on our network analysis. After network analysis may be same analysis we apply. That is called as a ground node. Any node voltage we specify with respect to ground only. So then only it makes some sense. Ground can be at any node, doesn't matter, but every single node voltage should be with respect to the ground node only. So let me explain. Let me give you that. Okay, so with respect to the ground node, or what we call reference बोलते इसको, which is always equal to 0, is my assumption. Assign the node voltages. इसको V1 apply करो, इसको V2. Any node voltage we should specify with respect to ground. Suppose if I ask you this node voltage, what is the node voltage here? Never say V of t. Some people, if you don't study all these things, you may say इस नोड वोल्टेज कितना? V of t. नहीं, इस नोड वोल्टेज का मतलब यही से ग्राउंड तक बीच में कितना वोल्टेज है, ये V of t एंड दिस दोनों मिलके बोलते इस नोड वोल्टेज। अंडरस्टैंड? चलो लेट्स मूव फर्दर। ठीक है, नाउ प्लीज लिसन, नोड एनालिसिस में 1%, 0.1% भी डाउट नहीं होना चाहिए। This is the very basic which comes almost in every problem, many subjects of your analysis. So learn this concept very clearly so that you should not have any minute doubt also in this. Okay, चलो listen here, the last point here, आप तो पहले केसीएल लिखो भाई, इसके बाद ओम्स लॉ लिखना चाहिए। सो लिखने समय पे हमेशा दिक्कत ऐसा होता है, यहीं पे नोड पे केसीएल लिखना चाहिए। ठीक है सर, assume 3 currents are flowing, ओके सर, डायरेक्शन क्या assume करना सर? कंफ्यूजन आएगा, मुझको पता नहीं V2 ज्यादा है और V1 ज्यादा है, V2 से V1 जाएगा और V1 से V2 जाएगा, हमेशा ये कंफ्यूजन आपका माइंड पे होता है भाई। सो इस कंफ्यूजन को अवॉइड करने के लिए हमेशा एक स्टैंडर्ड रूल ले लो, assume सारे करंट्स जा रहे उस नोड से, दैट इज दे आर लीविंग फ्रॉम द नोड, is the assumption. आपका एजम्पशन गलत है तो आपका आंसर में भी नेगेटिव, कोई दिक्कत ही नहीं है. मेक इट एज ए स्टैंडर्ड सो दैट यू डोंट गेट एनी कंफ्यूजन. सो व्हेन यू आर राइटिंग द नोड, फॉर एग्जांपल आप नोड 2 का नोड इक्वेशन लिखना समय पे आप एज्यूम all currents, you do reverse also, nothing wrong, leaving. Okay, that is assume v2 is more than any. It may be v2 minus v1 is my assumption, it may be negative, कोई दिक्कत ही नहीं है भाई. ठीक है. So IC assume कर रहा हूं मैंने, IL assume कर रहा हूं मैंने, IR भी assume कर रहा हूं. ठीक है. So what is your KCL? First at this node KCL क्या, IC plus IL plus IR इक्वल टू 0. इसके बाद ओम्स लॉ. ओम्स लॉ क्या है भाई, करंट इन द कैपेसिटर के लिए C dV by dt, बट द कैपेसिटर के अक्रॉस दो वोल्टेजेस है. आप ही बताओ V2 माइनस V1 लेना, V1 माइनस V2 लेना. प्लीज कमेंट गाइस, आप लोग ही कमेंट करना, V2 माइनस V1 लेना और V1 माइनस V2 लेना. आप ही बताओ यार, मैं वेट कर रहा हूं आपका आंसर के लिए. प्लीज रेस्पॉन्ड. रेस्पॉन्ड यार. C d by dt of V2 minus V1 or V1 minus V2. Come on, come on, come on, everybody, everybody. Very good, very good, very good. V2 minus V1. Now no confusion. Note 2 पे है तो assume IC leaving. So V2 minus V1 plus current in the inductor 1 by L integral minus infinite to T, voltage across the inductor V2 minus 0 plus resistor का current this voltage minus 0 by total resistance V2 minus V of T by R2 plus R3. Okay, so this gives you what we call the equation 1. We can say KCL plus Ohm's law. Got my point? KCL and Ohm's law together. आपको कुछ थोड़े से doubts होता है. I will clear it. Please don't worry. So here you may have the doubt. Sir, can you prove me why it is V2 minus V1? Why not V2 plus V1? Why it is V2 minus V of T? Why not it is plus? Why it is V2 minus V by R2 plus R3? Can you prove those equations? Definitely yes. Okay. So listen here. आपने कैपेसिटर ले लो. अंडरस्टैंडिंग के लिए दिस इज ऑफ नो यूज, केवल आपको समझ होने के लिए. Current in the capacitor IC assume किया ना, current enters from positive, leaves from negative, VC is the voltage across the capacitor. Now what is the current in the capacitor? C dVC by dt. इसका लूप इक्वेशन क्या, KVL. नेगेटिव टू पॉजिटिव V1, नेगेटिव टू पॉजिटिव VC, पॉजिटिव टू नेगेटिव माइनस V2. तो आपका VC क्या होता है सर, V2 माइनस V1. अंडरस्टैंड? नेगेटिव टू पॉजिटिव V1, नेगेटिव टू पॉजिटिव VC, पॉजिटिव टू नेगेटिव माइनस V2. सो आपका VC क्या होता है सर, V2 माइनस V1. VC is equal to V2 minus V1. Okay, so current in the capacitor equal to C into d by dt of VC, which is equal to V2 minus V1. Proved? It is not V1 minus V2, it is V2 minus V1 only. Another example, another thing. current in the resistor. Take the loop equation. Okay. So see what I did. I assume this is the current. Enters from positive, leaves from negative in the passive element is the polarities I have assigned. Okay. Now by KVL, V2 positive to negative minus, what is the drop here? IR into R2 minus V of t minus IR into R3. So IR into R2 plus R3 क्या होता है सर? V2 minus V of t. So आपका IR क्या होता है सर? Proved. 1 minute. यहीं पे R4 है तो you will get R4 in the denominator. Here if polarities are reverse, then negative to positive आएगा, then V2 plus V of t आएगा. So the blind rule here, in this particular node का voltage minus the remaining voltage, वो तो already negative है तो negative of negative क्या देते हैं भाई आपको? positive देता है. V2 minus remaining voltage by पूरा impedance is how you are writing the equation, because in the practice we don't remember, we don't do all these analysis, blindly we write the equation in a single step, so that you should know the background behind that. इसके लिए मैं इतना explain किया. So right, right. So lastly, the same question. चलो. Now let me write the equation at the node 1 without doing all these analysis. Single step में मैं node 1 का equation लिखना चाहिए. ध्यान से सुनो भाई. Okay. Assume same story. V1 greater than any. So here at this node, blind rule. What is this current entering? I of t. It's a current source. इसको Ohm's law कुछ नहीं इस पे apply कर सकते. But here, what is the Ohm's law? V1 by R1. Here, assume some current IC dash is flowing. Assume all are leaving. I of t is entering now. Minus I of t is leaving. So minus I of t plus V1 by R1. That is KCL and Ohm's law also together. Plus IC dash. Now ये क्या होता है भाई? C into d by dt of क्या होता है? क्या होता है? V1 minus V2 or V2 minus V1? V1 minus V2 or V2 minus V1? You are at the node 1. So what it is? Please comment. Please comment. V1 minus V2 or V2 minus V1 means it will be V1 minus V2. This is the equation to Ohm's law. आपको ये डाउट होता है भाई सर IC एंटरिंग है ना, व्हाई यू डोंट कंसीडर दिस एंटरिंग सर? यू कैन कंसीडर इफ IC is entering, what is leaving? Minus IC is leaving. What is minus IC? Minus of V2 minus V1. What is minus of V2 minus V1? V1 minus V2. So to avoid all this confusion, every time when you are writing the equation at a particular node, assume that particular node voltage greater than any other is always the easiest way to solve any question. Okay, so if you are okay, happy, we will move further. आपको कोई भी डाउट दिक्कत है तो बताओ. I am happy to help you. Please tell me. We'll solve the problems now. Very good, very good, very good. Come on, comment here. Everybody, are you convenient up to this? Are you happy up to this? Is everything fine up to this? No doubts, nothing. ट्रांजिएंट का मैं अपडेट करता हूँ यार, अभी तो शुरू किया ना, सो स्लोली एवरी मंथ वी कैन प्लान, डोंट वरी. ओके. Or yeah, what happened? Yeah, many people are in live. Why only few people are commenting? Everybody, please comment, and your comments gives me more energy. Okay, so comment that yes, sir, we understood, sir. Please move further, clear, sir. Everything you comment, whatever you feel, so that I can move further. आपको कुछ doubt है तो दिक्कत है तो भी feel free to ask me. It is a very very important, बहुत अच्छी basic foundation, solid foundation for your entire electrical engineering, guys. Okay. हमेशा बी एक्टिव इन द क्लास यार, एक्टिवली पार्टिसिपेट करो क्लास पे. मेश एनालिसिस वी विल डिस्कस टुमारो यार, बिकॉज आज पूरा थ्योरी हो जाएगा इफ वी डिस्कस मेश आल्सो. सो मेश को छोड़ दो, वी विल बी डिस्कसिंग टुमारो. सो लेट्स स्टार्ट द प्रॉब्लम्स. ओके, let me start with a good problem so that you feel more convenient. Okay, let's start with this simple question. Okay, in the network shown in the figure, V1 equal to 40 when R is 10 ohms. Okay, and R is 0 is the 0. The value of V2 will be. Question must be ideal to start. That's what I am checking. Which can apply. Okay, let's do this question. आपके लिए थोड़ा सा टाइम दे रहा हूँ, but I will do it. Don't worry. No doubt, no doubt, nothing. Okay, happy. So let's do this question here. First, basic question. The current I shown in the circuit below is equal to. Examiner को ये current चाहिए. Okay. So we need to find this current. Fine, no problem. Let's do node analysis here. Okay, I will do it here. Don't worry. Initial first questions, let me explain. You will understand the process. Then you can do also. I'll give time. Okay. So this is the node voltage V. Okay. So let me assume this is my ground. So let me apply the node analysis. Are you ready now? V minus this voltage by resistance plus V by this resistance plus what is the leaving current? 10 ampere plus what is this leaving current? V by 10. Okay, this is V now, 10 na? So this will be V by 10. So take LCM, V minus 10 plus V plus 100 plus V equal to 0. 3V equal to minus 90. आपका V minus 90 by 3 minus 30. आपका I कितना? ध्यान से सुनो भाई. I is this current. Is there any relation between I and this? It is inverse polarity. Minus V by 10. So minus V by 10 means plus 30 by 10. 3. So इतना आसान से you can solve the questions. Okay, so let's move further. Right, चलो let's move further. Anybody have any doubt in this process? Always you are welcome to ask me any question. No doubt, we will move to the next question. Okay, right. Do this question. Find the current I1. It's called dependent source. It is a dependent source dependent on this I1. We call this source value as 5I1 current source. Okay. So please try to solve this question just as previous question we have done. You can solve this question also. Please give a try. So then, as you people are coming tomorrow also, I'll plan at the same time almost one more marathon session. Okay. 1 minute, Prashant. Why we have taken at middle? You take here, here, it is same because all these three lines are same. Just for understanding, I took middle. Right. Chalo, please try this question. Tell me the answer. Comment your answer. What is your answer? मैं तो वेट कर रहा हूँ. Please respond यार. ज़्यादा time night, 20 minutes. We'll do few good questions and we will stop the session for today. Because unless we apply the theory which we discussed today, there is no meaning for what we have discussed. So let's do some problems, then you get the feeling of some completion. Then we can move. Four ampere, 4 ampere. Chalo, let me do it. Let me do it. Okay. So here also, I'm just applying there are many ways you can solve the question, guys. Okay. Yeah, I1 hai to, ye 5I1, this will give you 6I1, UP equation, finish. I want to explain by node analysis. That's why I'm going by this method. So let's take this node voltage as V. Okay. So now V minus 250 by 2.5, V by 10. What is the entering current? 5I1 na? So minus 5I1 equal to 0. But आपका I1 क्या? I1 is this current. This is 250 minus V by 2.5. 250 minus V by 2.5. Substitute here. Then what do you get? Take LCM. So 4 5 is 20. 20. So कितना आ रहा है भाई? 21 25. आपका V कितना होता है? Right? Because this you divide with 25. 100 into 60, 100 is 4. Right. So आपका I1 कितना? 250 minus V 240 by 2.5. 10 by 2.54. Just node analysis. I didn't apply anything. There is another simple shortcut method to solve this question is this one. You take this as 5I1. This will be I1 plus 5I1 is 6I1. Then just apply loop equation. Then what is the single step answer? 250 negative to positive. Positive to negative minus 2.5I1. Positive to negative minus 6I1 equal to 0. So 8.5 I1 equal to 250. I1 equal to 250 by 8.5. ऐसा भी कर सकते हैं. कोई whichever you feel convenient, you can use that. Right? Understand? Any method will give you same. So this is not 60 or 60. You will get the same answer. So इसमें 3 स्टेप पे आएगा, but I want to explain you the node analysis concept, इसलिए इतना किया. Okay. So this is another way to solve the question. Got it? Yes, no problem. Right. Chalo, one more question. This question I want to explain you just to give you the concept of ground properly. This is the question. Determine potential difference between PQ. P और Q का बीच में potential difference क्या कितना है भाई बताओ. Okay. So let's solve this question. Examiner has not given any ground. आप ही assume करना चाहिए. मैं तो यहीं पे ground assume कर रहा हूँ. This is VP, VQ, 10 assume कर रहा हूँ. ठीक है. So अभी node analysis अप्लाई करो आपने. कहाँ पे? At the node P. Then VP minus 10 by 2, VP by 8 plus 2 equal to 0. VP minus 0 by 8, VP minus 10 by 2. 2 is leaving, na? We are writing sum of leaving currents equal to 0. So 2 equal to 0. So take LCM. 4 VP minus 40 plus VP plus 16 equal to 0. 5 VP 24 होते हैं भाई. VP 4.8. The same way, apply the node analysis at VQ. Current entering the node 2 ampere, leaving will be minus 2. VQ minus 10 by 4. VQ minus 0 by 6. Take the LCM, minus 24, 3 VQ, 30, 2 VQ. So 5 VQ, 54. आपका VQ कितना? 10.8. So what is VPQ? 4.8 minus 10.8 minus 6. Right. Fine. ये क्वेश्चन तो बहुत आसान है, कोई दिक्कत ही नहीं है. But why I am explaining this question? Please listen. I want to give you the concept of ground for your better understanding. So listen here now carefully. Suppose the same question. Okay, I want to solve again, but I want to take the ground now at a different position. This I want to take a ground. With respect to ground, ये कितना होता है? -10. ये VP, VQ. Now आप ही बताओ, just by nodal analysis at the node VP. Okay, VP minus 0/2, VP minus of -10 plus 10 by 8 plus 2 ampere is leaving. Then you get 4 VP plus VP plus 10 plus 16 equal to 0. Okay, 5 VP equal to 26, VP equal to minus 5.2. Okay, fine. The same way, apply the node analysis at VQ also. So entering current is 2, VQ by 0, VQ by 4, because VQ minus 0/4. VQ minus of 10 plus 10 by 6 equal to 0. So minus 24, 3 VQ, 2 VQ plus 20 equal to 0. 5 VQ equal to 4, VQ equal to 0.8. आप ही बताओ VPQ क्या होता है सर? VP minus VQ -6. लिसन केयरफुली गाइस, ये वाला क्वेश्चन मैंने ऐसा सॉल्व किया तो -6 आया, ग्राउंड यहीं पे ले लिया, बट ग्राउंड नीचे भी ले लिया तो सेम और सेम और सेम आंसर आया -6. यू कैन अंडरस्टैंड VP VQ values not same, but VPQ remains the same. The voltage with respect to a node will change depending on the node you have taken, but the voltage difference will remain the same whatever may be the ground position you have taken. ऊपर ले लो, नीचे ले लो, कोई भी जगह पे ले लो, it will remain the same. It will remain the same. And also, so the potential difference will always remain same. You can take any ground, but never take ground for VP here and ground for VQ here. गलत भाई, ठीक है? Take VP VQ के लिए same ground. It can be down, it can be up, it can be here, anywhere. The potential difference will remain the same. Current difference depends on potential difference only. So आपका current measurement में you take any ground, no problem. Unless until examiner asks you specific node voltage difference के लिए any ground will not be a problem, because ground is just your reference. That is the point I want to give. That's why I have taken the ground at two different places and solved the question. Is this clear, everybody? Yes, VPQ is VP minus VQ. Surya. ब्रेक नहीं, क्लास छोड़ता हूँ 10-15 मिनट्स में. ओके, चलो. इज दिस पॉइंट क्लियर यार? आप लोग रेस्पॉन्स दे दो यार, क्या कर रहा है. ओके, इफ इट इज क्लियर आई विल गो फॉर द नेक्स्ट क्वेश्चन. ओके, you want me to continue for 10-15 minutes and finish the problems and leave the class, or you need few minutes break and again we need to continue? It is your wish. आप लोग बाकी लोग कमेंट करो. या आज ही फर्स्ट क्लास है भाई. थैंक यू. So the remaining students, no doubts, right? You understand the concepts clearly. No, कोई दिक्कत नहीं है ना, right? चलो. So let's do few more questions. Okay. So ये बहुत आसान क्वेश्चन है. You need to find the I1, I2. Just try this question and comment your answer. इसके लिए loop analysis, Kvl, KVL, if you know it, you will be able to answer it. 1 minute. Okay. Let's do this solid question. Then, okay, it makes more sense. Up to now, we have done some easy questions. Now, one more easy question है तो मैं देख रहा हूँ. Let me check. Okay, try this question. Then we will move for the remaining. I mean, this is also simple node analysis का question है भाई. Please go through this question. Thank you. So tell me the answer for this question. In the given circuit, the parameter K is positive and the power dissipated in the 2 ohm resistor is 12.5 kilovolts. What's the value of K is? आप केवल और केवल के निकालना चाहिए. एग्जामिनर तो बताया द पावर डिसिपेटेड बाय द 2 ohm resistor is 12.5 किलो वाट. किलो नहीं, वाट. ये तो आसान क्वेश्चन है भाई. केवल केसीएल आपको पता है तो यू कैन आंसर इट. ओके. टाइम देना. ओके, टाइमर जी आओ. आपके लिए टाइमर जी रेडी है भाई. So I'll wait for 45 seconds more. You can comment your answers. Surya Diya K equal to 0.5. Any other answer by anyone? केवल सूर्या दिया यार, बाकी लोग क्या कर रहे हैं? दे दो यार आंसर. मोर देन 35 स्टूडेंट्स तो है लाइव पे, क्या कर रहे हैं? एक ही आदमी राइट आंसर दिया. बेल रिंग हो रहा है. नो राइट आंसर बाय एनीबॉडी. व्हाट हैपेंड? लिसन. चलो आपके लिए मैं सॉल्व कर रहा हूं. फर्स्टली पावर इज इक्वल टू 12.5. Can I write this as V naught square by R, which will tell me my V naught square equal to 12.5 into R. R is 225. V naught equal to plus or minus 5. आप प्लस 5 भी ले लो, माइनस 5 भी ले लो. ठीक है, मैथमेटिकली दोनों सही है ना. सो आप प्लस 5 ले लिया तो 5 by 2 will give you here 2.5. And this is kV naught and this is 5 ampere. हो गया. KCL चाचा को बुलाओ. करंट एंटरिंग 2.5, लीविंग माइनस kV naught प्लस 5 इक्वल टू 0. आपको पता है V naught is 5, so minus 2.5 plus 5 equal to what is your K? What is your K? आपको पता है नहीं, but V naught is 5. So K कितना? ये 2.5 by 5. 0.5. Let's take this case also. K equal to minus 5 means reverse polarity में 5. In this case इस डायरेक्शन पे 2.5, इस डायरेक्शन पे 5, इस डायरेक्शन पे kV naught. So and leaving current is 2.5, kV naught is entering and 5 is leaving, and 2.5 k is how much here? So V naught is minus 5 now, minus into minus, plus 5k plus 5 equal to 0. 5k कितना? minus 7.5. k कितना? minus 2.5. but this is wrong क्योंकि examiner already बताया k is positive. So only this is the right answer. Got my point now? It is also right. Simple, what we call KCL only. Simple KCL, KVL पता है तो you can solve this kind of complex question also. Right, very good. Geeta दिया minus 0.5, नहीं. K is positive plus 0.5 only. Praveen तो 5 दिया, no issue, fine. Try तो कर लो भाई. Right answer, wrong answer doesn't matter anytime. Okay. So this we do tomorrow, KVL. Okay. Which of the following equations is valid for the circuit is the question by examiner. ठीक है. केवल और केवल KCL का क्वेश्चन है ये. आप लोग ट्राई करना चाहे तो ट्राई कर लो. मैं थोड़ा सा टाइम देता हूं आपके लिए. थोड़ा सा ऊपर गया क्या क्वेश्चन? विच ऑफ द फॉलोइंग, इस फिगर पे ये चारों में कौन सा इक्वेशन सही है भाई? दिस इज द क्वेश्चन. Time up. Right. Firstly, at this junction, okay, I1 is entering, I2 is entering, I3 leaving, I6 leaving, equal to 0. So ये इक्वेशन नहीं दिया एग्जाम में, क्या करना? I3, I5, I6, I7 का दिया. I3, I5, okay. Don't write this. Okay. At this node, I5 is entering na, minus I5 minus I3 plus I4 equal to 0. Right. So आपका I4 क्या होता है सर? I3 plus I5. Similarly, at this node, I6 is entering, I4 is entering, I7 is entering. But what is your I4? Or you can say I4 plus I6 minus I7 equal to 0. But I4 कितना? I3 plus I3 plus I5 plus I6 minus I7 equal to 0. Option D. Option C दिया NS. Option D is the right. Basic KCL का question. Okay. Right. चलो. That's all for today. I hope we can end the session. यार, what do you say? This question is a very good question. कल करेगा ये वाला question. ये तो state equations बोलते. Okay, we will do it tomorrow. Get ready for that. Tomorrow ये सारे questions करके mesh analysis करके कुछ और techniques भी देता हूँ आपको equivalent circuits के बारे में. Okay, fine. Let's end the session for today. I hope you enjoyed the session, guys. I hope you learned the basic techniques to solve the problems. Okay, आप ये homework ले लो आज के लिए. मैं कल solve करता हूँ ये. ठीक है, take a screenshot. ये भी homework ले सकते हैं आपने. We will discuss it tomorrow. This one also. Right. So guys, that's all from the content point of view. And Unacademy पे YouTube में आपने free classes attend कर रहा है ना? Please try special classes from Unacademy Learning app also. You can follow my profile that might be available on the chart also. So if you see the special classes में बहुत ज़्यादा features है आपके लिए, because those are dedicated learning platform पे if you study, you can interact with us more, you can ask it out, you can talk to us, and you have the more what we call interactive sessions, participate in the polls and all. You can feel the difference. Okay. And yes, this week we are giving the best, that is Unacademy Ultra Combat exam. So chance have a chance to win up to 100% scholarship. So on April 24th, that is this Sunday 11 a.m. Don't miss this opportunity. You can enroll using my code Shankar10. That if you want to enroll for an Unacademy Ultra Combat exam, link is available on the video description. Happily you can enroll for this. Okay, so these are our toppers this year from GATE and ESE. Okay, and I'm sorry, yeah, these are the batches going to start today. I mean 2 days back, and you can call to our Unacademy number for any kind of queries regarding the batches, whatever might be the details you want. You can call to this number. Okay, so whenever you want to take the subscription, remember the code, guys, Shankar10. Okay, so this is for Unacademy, what we call test series के लिए आप subscribe करना चाहे तो you can subscribe. I already told you physical notes is also be given for iconic subscription students. Okay, so this is our campus placement drive training for them. Presently, these are the batches going on. So thank you very much for your time. I hope you enjoyed the session. We will continue with the same energy tomorrow also. Okay. I will bring more and more such kind of sessions. Always happy to help you guys. Okay. Thank you. टेलीग्राम चैनल ओके सूर्या प्रेजेंटली क्रिएट्रिक्स का टेलीग्राम चैनल पे फॉलो करो वहीं पे मैं नोट्स देता हूँ यू विल गेट ऑल अदर डिटेल्स एंड आई विल आल्सो प्रोवाइड यू माय ऑफिशियल टेलीग्राम चैनल it is under the progress I will update you soon for that details also okay tomorrow also we will meet at the same time thank you okay. Bye bye. Love you all. I hope you enjoyed the session, guys. I hope you learned something from these 2 hours. I definitely enjoyed these 2 hours with all your participation. And I'm always happy to teach you people, guys. It makes me more and more happy. Love you all. Bye bye. Good night.